Okay, it's so good to see all of you. Sorry about missing on Monday. You likely got informed from UNF that you maybe were exposed to things. I chose to get tested. If you don't know, UNF is offering free testing. You can go. It is outside. It is kind of sweaty. If it is raining, it will rain on you. It's not an outside structure that is not waterproof. Like, just so we're clear, I brought my laptop and it was like, oh my God, this is uncomfortable. If you are ill, look, it's a really terrible recording, but it's the best way that I can make this work in my life. So I will record it. I'm trying today, so if you ever see me looking at my computer trying to figure it out, one of the things I realized is I spent the entire course like right here, to where it's just like one arm on the video, and I wrote all over the board, and you couldn't see it, which is worthless, right? So we're going to try to fix that. It doesn't have any slides, so the slides are up here. The slides are on Canvas. We can kind of figure that out. So today is lecture 4. Next Monday is Labor Day, so there is no class. You can spend the day at the beach, spend the day studying, really do whatever you want. On Wednesday, September 8th, so 1 week from today, is our first mini exam. So that mini exam will cover lectures 1 through 4. So this is lecture 4, so it covers all of chapter 1 and all but a single part of chapter 2, which we'll talk about as we get into the material. It will be at the end of class. It's 100 points. I will provide a periodic table. It will look like the green sheet that I gave you. The front side, the side that says periodic table. I will also provide any equations and conversion factors that you need. The things that you need to memorize are the singular table in chapter 1 with like kilo and mega, micro, those values. So like 1 times 10 to the 6 or 1 times 10 to the negative 6. You can memorize those. It'll be 35 minutes. So your ALEX scores for the prerequisite knowledge in chapter 1 have populated to Canvas, right? They are all there. I spent time doing that. So hopefully you've seen those. ALEX and Canvas are linked, but not like wedded together. So your scores, I will populate them for you every 2 weeks or so. So it'll basically just pop up like, oh, here they are. So the scores that you got were for completion. The PI score will show up at the end of the semester. Any questions about ALEX? Scores? Anyone having any issues with ALEX? Other than the atomic weight ones, and we're going to work some examples for those in case you're like, this is terrible. I'll fix that. So ALEX, after this week, you should see a knowledge check, which is like that initial knowledge check. So the thing with ALEX, probably the thing that's annoying, is the fact that it's going to ask you to do the same type of question. You have to get it right 3 times in a row. One of the things that ALEX is good but annoying about is the fact that it's going to ask you, it's going to help you learn it, and then it's going to wait 2 weeks, and it's going to be like, did you learn that, or did you fake learn that? So I think that's a really great thing, which is why we use ALEX. The problem is, so your pie grows, and then you have a knowledge check, and if you didn't learn it, it will take it away. And you're like, this is horrible. So later in the semester, there are these things called Open Pie, which is basically a free-for-all. You can do all of the homework during Open Pie. You can access Open Pie by finishing early. So if you didn't do the first assignment, 1, it will pull anything you need into this. So if you don't finish this week's assignment, next week you will have more objectives than other people. Because it basically says, excuse me, you need to know how to multiply things in order to do this, which is appreciated to some extent, but annoying on the same extent. So if you stay on top of it, you should have 10-ish objectives every week. You can work those. If you have issues, you can always send me an email. ALEX is due Monday of this upcoming week. Chapter 3, the slides will go up on Canvas by Friday, in the same place where the chapters 1 and 2 is. We will start that probably first thing on Wednesday. I keep saying Monday. Yeah.
So the knowledge check is due Monday?
So all of that will just be assessed through Alex. So it should not populate for you unless you have finished the objectives. So you should have the chapter 2 that you're working on. When you finish those, it'll be like, do you want to take a test? Probably equally annoying as that. You can wait to do that until you start the next week. It will just take time. So if you like to do your objectives on Monday, so not this upcoming Monday, you'll have finished chapter 2, but the one before, it will force you to take the knowledge check. It's kind of one of those weird gates that you can't avoid. There's supposed to be a way that you can say, give me 24 hours. You should see that. You would say, okay, start. And then you would, in the first problem, it should say delay for 24 hours. But I don't know where that button goes. I can see it in my version, but no students tend to tell me they can see that. It is set up and enabled on mine. If you see it, let me know. If you don't see it, also follow up. Any questions about this information? Any questions about the mini exam? Yeah.
Do you have to know the polyatomic ions for the exam?
Ooh, that's a good question. So the question is, do you have to know your polyatomic ions? The short answer is no for this one, yes for the next one. And as soon as we finish announcements, I will tell you what's on that sheet, what you have to know, both now and in the future. If you might be wondering how many questions are on this, I don't know. I have written on my to-do list, write mini exam. I've not opened a Word document. I have not even given myself the old, like, what's going to be on that? Some weeks I will be able to say there are 5 questions or 8. This time, likely on Monday, I will know, but I will not see you on Monday, so. Any other questions?
So chapter 2, part 1 is due this coming Monday, and then the knowledge check will be due after that, right?
Yes.
Okay.
For Alex?
Yes, for Alex.
So you might be thinking to yourself, oh my God, I now have to study for this course. So, a couple of ways that you can do that. So on Monday, Tuesdays, and Wednesdays, for this week, I sat in my Zoom room by myself. All by myself. So, which is fine, but that's where you can get one-on-one help with me. If, perhaps you're like, you're a bit much, lady. I don't ever want to see you outside of this 75 minutes. That's totally acceptable. You can also attend SI. So to get to my office hours, they're on the front homepage where it says office hours, and then there's like a little Zoom link. You just click it. It will say, do you want to go here? Say yes. I'll be there. Probably jamming out to some, like, lately it's been some 90s country, so I'll try to turn that off before we talk, but you never know. So SI, if meeting with faculty is not high on your list, that's okay. I'm not offended. So supplemental instruction starts Thursday. So this is a student who has been previously successful in my course, top 5%. So why don't you tell them where it is, what you're doing this week?
So my first session is going to be tomorrow in building 2. Does anyone not know where that is?
I feel like we have a few people who are quietly giving me, I have no idea where building 2 is. I don't know where building 2 is.
It's the building across Chick-fil-A. It's upstairs. That's where the session's going to be. I don't think they'll have signs. But if you have any questions, just email me. I will come down and help you out. But yeah, my first session is tomorrow at 4:30 in building 2. We're going to be going over atomic weight, dimensional analysis, all the math that we've covered so far. You'll get a preview of that in class today. I have another session this week at 1:30 on Friday. Same room, same building. So yeah, Tuesday sessions are through Zoom at 7 o'clock. You should have gotten an email. Have you guys been getting my announcements, by the way? Okay, cool. I support this section and the section before that, so I usually go to that after. That's why you also don't see me a lot. But if you have any questions, you can just message me on campus or email me. I'm happy to help. Does anyone have any questions?
If you can only attend half of the section, you should still go. I'm a big advocate for SI. I will continue to push it all semester. Routinely, students tell me that they just want more examples. there's a limit. Today we're going to do only example problems, so obviously it's possible. But I think it's a trade-off with trying to watch videos or do something else in order to do all problems. And so this is another way for you to do that. Typically there's a handout. You do have to go to get said handout. None of them, as far as we're aware, will be recorded or anything else. You should go. It'll be great. It will be people outside of this course. You might meet your friends. So I also teach this class at 3 o'clock on Monday, Wednesday. So basically when I get here, you get to see the second version, which is usually better. Not always. It's hard to say. So does anyone have any questions about what SI is, what might happen? I'm a big advocate. Yeah.
So if there's SI for 2 different times, you're taking the JD at like the same time, or would you do both at the same time in the same room? Does that make sense, or would they be separate?
So they should be separate. So I have only been to SI at Texas A&M. Just like, I don't want to say a long time ago, but like it was there for my courses, and I was like, oh yeah, extra help, yeah. So the one I went to, she had practice quizzes. It was like her big draw. It was great. That's how I passed that class. So in this case, there will be, maybe not practice quizzes, but there will be assessment type things to give you that kind of information. If you're looking for like your biology ones, they may be in the same location. Hopefully they will not all be at the same time. Usually they tend to overlap. So I had a student in my first lecture who said, well, it ends at 5. Can I go to the other one? Yes. You can just basically like go from room 2202A to 2202B at 5. Our only request is that you don't just like roll in, snag the worksheet, and roll out. It's kind of disheartening for everyone involved, but that's about it. Any other words of wisdom? No.
Your mini exams next week, so we can start studying. Like that.
Yeah, the mini exams next week. This course feels like we're kind of going kind of slow. I feel like we're about to like explode off of the platform here and start moving. I mean, it's the 4th day and I've only been here twice, so like it's fine. But we are going to start moving and adding in stuff that you likely don't know. So make it a good habit to go to SI. Research has shown that students who attend and participate tend to get a half to a full letter grade higher. I had a student who was like, I'm not showing up. How come I'm not getting anything? He showed up and watched movies on his phone. So like, you will not get much out of this if you do not actively participate. It's the same if you came in here and watched TV. You're here, you might be learning, maybe not. Any other questions? Yeah?
Yes, I just transferred into this class. I was
Oh.
here Monday, but we lost it.
Oh, I'm so sorry.
And so we have a quiz in a week. I also have a class from 4:30 to 6:30 tomorrow, so I can't attend the SI, and I also have class Friday, so I can't attend that SI either.
Looks like Tuesdays are your best option.
So that's the best option for me to get caught up on everything.
Yeah, so SI runs independent. So if you take, is it physics where they're part of the course? So if you are also enrolled in physics and they have PES, I don't know what they're called in physics. They have something else where it's like mandatory. These are optional, but strongly recommended. So in SI, they will work extra problems. So you can, if you have friends that go, you can like, hey, give me some info. And do that for any of the ones that you miss. But most of the time, it will just run kind of whether or not you're there in that case. And so if you can only go 1 day a week, you will still consistently benefit from that. And starting this week, you'll send out a detail-ish schedule.
Yeah, I'll send out an announcement tomorrow morning with details like what I'll be covering on Thursday and Friday. And that will happen every week, so you kind of know what you're getting into.
And then the stuff on Alex was what we've covered in class so far, or is it different?
It should be what you've seen. Stop by after class and we'll make some sort of a communication about where you are and what needs to be done.
Okay, awesome.
Because have I sent you a bunch of emails about how you don't have an Alex account?
No, I've done all
Ooh, excellent. I feel like I've accosted a lot of other people. Like, hi, are you doing homework? Are you doing homework? Yeah. Sweet. We'll catch up at the end of class and make sure you have all of the right things. But Alex is a good review for what we have talked about. Any other questions about Alex, SI, office hours, Gen Chem 1, I don't know, college football? It starts this week. I mean, oh no. Technically it was last week, but I watched game day and it was weird. That's all. Excellent. So, you may have seen yesterday that 3 assignments populated, but I forgot to unlock the module that I put them in, so like they're there, but not. I will unlock it as soon as I walk back upstairs. So your chemistry and life assignments, there are 3 of them. A lot of people think that chemistry is, we could list every bad adjective for this course. I hate it, it's so dumb, so-and-so made me take this, I really wish I wasn't here. I think the reality is that chemistry is a part of our day-to-day life. And so what I would like you to do is to make 3 observations outside of class. If you do research, because many of you have, I don't want to say adult jobs in this course, there are a plethora of you who do things outside of go to school full-time at UNF. You may encounter things at your job that are chemistry related. Feel free to use those. What you cannot use is your Gen Chem 1 lab. Like, that's silly. That's not your real life. I'm talking about your, like, not real life. So if you do research, if you work at Mayo, if you, we could list all kinds of things, you might encounter chemistry everywhere. The idea is to take a notice of 3 different times that you see chemistry this semester. You are going to include a photo inside your Word document, and then you're going to write 300 words. Not like a diary entry, but like, what did you see? Where did you see it? What did you learn? How did you learn? The idea is to make us be more aware of what it is that we are encountering in our life. There are lots of different things. I don't know, you could go to Home Depot and be like, this plant food has some weird chemical compound in it, and be like, I now know what that means. This is not meant to be a hard assignment. It is meant to literally give you the opportunity to open our eyes. You could watch old 90s like sci-fi shows and tell me why their, I don't know, mass spec isn't right. You could watch current things. You could watch some Netflix show that's like a documentary where they use like genetic testing or something else. There are lots of options. Here are the things that are not gonna cut it. If you do something illegal and read about it, somebody was like, can I make explosives? And I was like, no, I don't wanna know. What you do in your personal life is your business. If you do this, I am bound by law to report it to someone. They may not care, but I will report it. So please, nothing illegal. 2, there's something else with this. You need to include a photo. If it is something that you saw on Twitter or something else, feel free to include a link. If it is a show, you can tell me where you saw it and what episode it was. I'm always looking for cool things to watch. Nothing illegal, can't be inside of class. It should be during this semester. So if last week, I don't know what you guys did for fun last week, but if you shot off fireworks, that would count if you had a photo. Watching a rocket launch 3 years ago, no. Questions about the chemistry and life. You're gonna upload a PDF. If you do not, I mean this in a super genuine way. If you do not know how to generate a PDF from a Word document, I will meet with you one-on-one on Zoom and actually show you step-by-step how to do it. It's kind of a crazy time. Ordinarily, it is not difficult. I will show you. I know how to do it on a PC and a Mac. I had a student once who would print it out and then scan it back in, and I was like, do you know you can click this button? And the student was like, I quit. So it is totally okay to be like, I don't know how to do this. If you're like, Malcolm, we all know how to do it, that's fine. Somebody might not. You are also welcome to go to IT. They will not be as helpful as I am, just to be frank. Any questions about this? Yeah.
So if we see it in like a show, can we just like take a picture of really like the TV screen and just like describe it?
Yeah.
Like of like the actual like scene?
Mm-hmm. So you can take a picture of the screen, you can take a picture of, I mean, if we think about just shows on Netflix, like you could, I don't actually know if Breaking Bad is still on there, but you could do that. The only other caveat with this is they are all gonna run through Turnitin, So if you are feeling exceptionally lazy, and you're like, hey, you do the first one, I'll do the second one. Both of you we're all gonna have to talk about it. Please don't copy and paste directly from the internet. I'm not grading on grammar. It's 300 words about what you saw, what you learned, and everything else. I will also accept things if you are like, so the Nobel Prizes come out in a couple weeks. If you are interested in a Nobel Prize that is chemistry related, you can write about that too. I'll tell you when those come out. It's like draft week for scientists. I'm not saying I get excited, but I do. Any other questions about this? It is through Canvas. You'll turn them in there. I will grade them there. When I go upstairs, they will all be open. So you could turn in all 3 of them this week and be like, I'm never doing anything else. I will grade them on those dates. Well, not on that date. On September 29th, October 27th, and December 1st. You can turn them all in now. That's totally legit. If you only turn in one, make sure it's the one that's due first. They're in order, so it's like 1, 2, 3. Just make sure you don't turn in the December one for the September. We will make it work because I'm not a monster, but it will make my life easier if you do the first one.
I was just wondering, where can we find that file?
That information is directly in the assignment, and that is on the modules page, I think. I forgot to unlock it because I was like monkeying around in there yesterday. I think it's right after the slides. So when I send a weekly announcement this week, I will basically just put a hyperlink into it just to get, so that if you need that information, you can find it. Any other questions about this information? Anything else? Yeah.
Is there a certain heading we have to have on the paper?
I prefer that it has your name on it. I forget that there are other classes that care. No, I don't. I would prefer that it has your name, so that when I read it, I feel like we're bonding. That sounds super creepy.
Is it easier also to put like 1, 2, 3 on the document so that like you know like which one's 1, 2?
So it turns out, so the question is, should we annotate different documents? You will basically, there are 3 different assignments. So you can put that on there for your own records, but they will all be in one place, and I'll basically just click through and read them all at once. So, other questions? When we get closer, I will pull up Canvas in here and show you where it is and show you like what it looks like to upload things if this is your first semester at UNF. Not as common in here, but there are some of you who are like, I don't know how you upload things. I'll help you. Any other questions? Sweet. So, in front of, hopefully all of you, you have a green periodic table. From now until eternity, and by eternity I mean mid to late December, you need to bring this with you. Anyone else not get one? Did you get one? Anybody else? So this green sheet is our periodic table. I'm not saying it's your new BFF, but it's pretty close. On the side that looks like a periodic table, at the bottom, it tells you what you need to know. So the first 6 rows, in the top part, you need to know. And you're like, what all do we need to know? I know that there are some quizzes where they will give you a blank one of these and be like, please fill it out. That's like a lot. That's not what we're doing. I want, if I say iron, that you know that that's Fe. If you see MO, that you know that that is molybdenum. So I'm asking for you to memorize elements 1 through 86, not 57 to 71. So if you're like, oh, at the top, this is what I want you to know. Everything down here pretty much is dead to us. I'm not saying that they're not important. They're very important. We're just never really going to talk about them. So you just ignore those from your life. We'll leave them there. So when do you need to know this? By mini exam 2, so whenever that is, so not next week. You need to know all of those. So for mini exam 1, your periodic table will have the names. I like to give people more than enough time to memorize things. I think a week to do a bunch of memorization is it's a lot. So you have, I think, 3 weeks to memorize all of these. I would recommend that you start sooner rather than later. On the back, this is your common ion table. I linked it in the announcement on Friday. On here, it feels like there's a lot going on. Most of the stuff on the left, you can kind of ignore. You need to memorize all of the polyatomic ions. Those are the, not just F minus or O2 minus. You need to memorize these. On Alex, they have another version of this chart in what feels like a routine statement. It's like this, but more. You are not responsible for those. Use their chart whenever you need it. On an exam, or a mini exam, or a midterm, or I don't know, whatever assessments I give you, I'm going to pull stuff from this information. So you are responsible for this. The other thing on here that you do not need to memorize. On the left side, for copper 1, it says like copper 1 or cuprous. We're not going to use the Latin-esque names. I will always call something copper 1 or copper 2 or any of the others. So that's true for like anything in the 2+ or the 3+. You could just like marker that out. I thought about doing it for you, but I forgot until I'd already hit print and I was 100 copies in. So like I was like, we're just gonna roll with this. You can just mark that out. You do not need to memorize that information. These, for the parts where you will see it on the mini exam 1, I will give you the chemical formula and not ask you to name it. So we're gonna do an example that will explain what I'm talking about. So any questions about what on the periodic table, front or back, you need to memorize? Yeah.
Do we need to memorize the mass as well? Like, know it by heart?
That is a great question. So the question is, do you need to memorize the mass? Absolutely not. Not even a little. Like, you don't need to memorize the mass. You do not need to memorize the atomic number, which is the whole number in the top left. The only thing that will be different between this copy and what you see on the exam is that the names will be gone. That's the only difference.
So you only want us to memorize the name of it, not the whole symbol?
So I want both. So I want you to be able to, like in your mind, if I say that potassium carbonate, that you'll be like, okay, that's K, carbonate, carbonate. Okay, CO2, 3. That's what we're asking you to do. That you need to have those memorized. I will expect that you have them memorized for mini exam 2. For mini exam 1, I'm going to give you this periodic table. For mini exam 2, it'll be this, but like the names will be wider. I mean, it's a different version of this. It just doesn't have names.
Thank you.
Yeah, no, I want you to have plenty of time. But going forward, I will expect you guys to know that. But if you bring this with you, there's nothing wrong with flipping it over and being like, what is it I need to know? Other questions? I do want to reiterate, I will under no circumstances give you a blank periodic table and ask you to fill it in. I feel like every semester someone's like, I'm ready for my periodic table quiz. And I'm like, we're not doing that. So I have this tacked up behind my desk, both at home and at work, so that that's where I leave mine. If you want extras, I have them. If you lose them, I will always have extras all semester. Any questions about the videos that you guys watched? How many of you guys watched? Yes. Those are not my best videos, because I had to watch them to make sure that I knew what was happening. Unfortunately, they were very early in the semester, and so my cinematographic skills got that. There's less tapping, because I figured out if you wore headphones, it was not quite as loud. But I don't think that really matters. Did we finish the honey soy chicken recipe question like a week ago? Oh, we have a question.
So, for the people who discovered everything, do you want us to remember the names and dates, or just what they discovered, like what they contributed to chemistry?
Yeah, so the question is for, I think it's part one, where I talk a lot about who discovered what. I think the history is really important to present. I will not ask did this, or when did this happen. I will ask you, like, what is an electron? Or what is the plum pudding model? I always love that question. Something where it's like, what did you learn? But I will not ask, like, it will not be a detailed question. I'm also not going to ask, like, please give the definition for this. Like, what is a molecule? I'm not going to ask you that. But I will ask you which of these is a molecule, which is using said definition. Other questions about the videos? Excellent. Did we finish this example? No.
I don't think we did it.
Did we do the example before that? Did we do this one? Well, we'll start with the international barrels of oil, and then we'll talk about honey soy chicken. Say that one more time. This is out of chapter 1 slides. It's slides 32. Yeah. The slides that I'm going to use after this, I will post after class. Because today what we have is a plethora of example questions. Ooh, I forgot to tell you. You needed to bring your, next week for the mini exam, please arrive with a calculator that cannot graph things. If you're like, is this the right kind? Feel free to pop by after class, or when I wander around, you can ask. If it graphs, no. If it's like this thick and a screen like this big, probably also no. You know, if it graphs, if it doesn't graph, it's fine. If you have the business calculator, so it's like a SAD 4-function calculator, and you would like to borrow one from me, I'm happy to loan you one. Someone always tries to do it with a calculator that only does like addition and subtraction. It's possible. It's just a lot of work. Bring a calculator, bring a writing implement. That's all you need to bring. Everything will be here for you. You can write in any color you like, preferably not red. But if that's the only pen you have, that'll be fine. I will make adjustments as always. So in this question, an international barrel of oil in the market is equal to 1.33 U.S. barrels of oil. Currently, the price of oil is $48.52 per international barrel. What is the price in dollars per gallon if 1 U.S. barrel is 31.5 gallons? So in this case, just make a mark. Now I don't have to do that 42 times. So in this case, we have our price of $48.52. And in this case, it's per international barrel. So in this case, it feels like it's a weird unit conversion, right? It's not necessarily, we're not converting like grams to kilograms. We're converting international barrels to U.S. barrels. So in this case, we know that 1 international barrel is equal to 1.333 U.S. barrels. And we know we are looking for the price per gallon. And so 1 U.S. barrel is equal to 31.5 gallons. When you plug this into your calculator, you should get 1.15526. How many significant figures should your answer have? Got a vote for 3? Seeing lots of 3s? You are correct. There should be 3. With rounding, it is $1.16 per gallon. So what questions do? Yeah. So are you asking how many sig figs this value has?
Well, yeah, I know that usually it's gonna be 4 because for the figures I get that, but in other scenarios, if that was like the lowest number of figures and figures, would we still say that's it? So we would count sentences and things like that.
So is your question if it had been 13.50 and our final answer would have been $1.15.5?
It did.
really murky place. We're almost never going to be in dollars. Again, just a random example. So in that case, you would use the full number of significant figures, knowing full well that, like, financially, you would either have $1.15 or $1.16. You would never really have 15.5 cents. More than likely, we wouldn't see that in class.
Do we always have to show our unit conversions like this?
So the question is, do you have to show your unit conversions? It probably doesn't need to be as detailed. So I want to say yes, but I know that many people are like, I just don't want to write all that down. The amount of work that you show needs to be enough that if you get the wrong answer, I can award significant partial credit. So however you demonstrate that, and this is not a packed class. If it was a packed class and you always had the right answer but no work, we'd probably have a convo about where are you using your eyes, are you doing it? So I prefer to show work. I will always show you the most detailed way to do it so that later you could not. But if I was doing this myself, mine will probably be a little bit more compact. So however you get to the answer is fine. But if you have no work, partial credit is significantly more difficult. So the flip of that is there are a number of problems, and some of which we'll do today, where there is no work. If I ask you how many protons, neutrons, and electrons there are, you don't need to I read the periodic table, I'm not asking for that. But if you do a long calculation, the more detail you have, the more likely I can give you as much partial credit as possible. Other questions? Excellent. So let's talk about some honey soy chicken. So I think what I will do is I'm going to give you guys about 2.5 minutes to see if you can see how far you can get. So a recipe for honey soy chicken calls for 63.9 grams of honey. How many tablespoons of honey does this recipe call for if the density of honey is 1.42 grams per mil? And 1 tablespoon equals 14.78 mils. If you do not have a calculator, I would suggest busting it out. I'm going to wander. If you have a question, if you're like, I don't know what to do, just ask. I understood what it is that you meant. How's it coming? I don't want to say are we having a good time, but how many of you feel like you are getting to an answer? How many of you were like, this is not fun, I'm not having fun? Okay. Medium entertainment in there. So in this case, we want to use the density, and then we're going to do a unit conversion. So in this case, your recipe calls for 63.9 grams. And so we're going to use the density, but I'm going to flip it over of 1.42 grams in 1 milliliter. From here, so our grams, we've gotten rid of those. Then we're going to convert in 1 tablespoon. There are 14.78 milliliters. So we should get 3.04 tablespoons. Questions? I also have a very excellent recipe for honey soy chicken. If you're like into needing new recipes, you can just shoot me an email, send you a link.
So I did it a completely different way with some of the right answer.
Then your method is great. So the question is, I set this up an entirely different way and I got the same answer. I'm not overly particular about methods. The only method I will take off points for is using your eye keepers on your neighbor's paper. You can set, with a lot of these conversion factors, you could have set them up almost in infinite different methods. As long as you're using the same methodology, I don't want to say I don't care, because that sounds heartless. But I think it's open for interpretation how you get to that answer. Good question. Any other questions? Sweet. So that wraps up all of chapter 1. And now let's look at our example questions for chapter 2. So these are not yet on Canvas. They will be on Canvas. I don't know, as soon as I go back upstairs. So today is just a series of review questions. Starting next week, we will return to the lecture, not a chit-chat lecture, but I will lecture right on the board and work examples as we go along. But this is just to make sure that after the videos, we're kind of all on the same page. So this first question asks, a certain chemical reaction releases 32.2 kilojoules of heat. For each gram of reactant consumed, calculate the heat produced by the consumption of 3.1 kilograms of reactant. I'm going to give you a couple of minutes. If you struggled on the first one and still have your work, I'm going to wander. If you have questions, if you don't, just keep working, and in 2 or 3 minutes, I'll write the answer on the board. how many of you have achieved an answer? How many of you are wandering through the lost land of calculations? It's an okay place to be. It's only the second week of class. We're going to get there all together. So in this case, this is actually a dimensional analysis. Now, it's going to use a bunch of chemical terms that once we get to chapter 5, you're going to be like, I've seen that before. But the reality is, dimensional analysis, we could convert anything to anything else using conversion factors. So in this case, we're going to take our 32.2 kilojoules for 1 gram. And from here, what we're going to do is we want to know how much energy it is if you use this many grams. So multiply by 3.1 kilograms. Now in this case, grams and kilograms are in fact not the same unit. So we need to convert. You could have immediately converted 3.1 kilograms to grams by multiplying by 1,000. You can also show that calculation. So 1 kilogram has 1,000 grams. And this is 99,820 kilojoules. So how many significant figures should your answer have? I'm seeing some 2s and 3s. So the first number you see has 3. The second one has 2. Because we multiplied them, it will be the value. There should be 2. So here, if this value, so the problem is that once we do this, we need to round until we get 100,000 kilojoules. So the downside with 100,000, which is the right answer, is there's not really a good way for you to just like add a decimal point. So if it was 99 and this was like a 3, you could have just written 99,000. This value would have to be converted into scientific notation, which is 1. Nope. It is 1.0 times 10 to the 5th kilojoules. What questions do we have about this calculation?
To get into the scientific notation, you move the decimal point right. 5 places or
To the left.
to the left?
So if it is, well, from which one?
From the 100,000.
From the 100,000, so you count over the number of decimal places, so it would be 1, 2, 3, 4, 5. And because, so you almost always are moving to the left, usually. If it is a big number, it is a positive exponent. If it is a small number and you're counting back to 0, then it would be a negative number. More often than not, is this true? Yes. More often than not, when we see scientific notation, it will already be that way on your calculator. Because we'll see this when we're using really big numbers or really small numbers where it already starts with exponents. I will never require you to put something in scientific notation unless this is the answer, and then you can't have sig figs in this value. Questions? Yeah?
Why did you round those to 100?
So you can only have 2 sig figs and 99.8. It's a good question. It's been a long day. Other questions? So someone, I think, it might have been in this class, might have been in the other class, sent me an email today that was like, look, how on earth are we supposed to do these abundance questions? Alex and I disagree over the right answer. So we have 2 examples, this one and then one in a little bit. So last week we talked about significant figures, and I said there was one set of objectives where it was going to be really painful. This is it. After this, sig figs will just become a little bit more intuitive. I'm going to show you the 2 different types that you will see in Alex and on my assessments, so that you can basically, if you write this down, you can recreate it at home. Also, if you get stuck, feel free to send me an email, include a copy of your work, and I can pretty much guide you to the right answer via email. So scientists collect the following data about ruthenium. Ruthenium 99 is 97.3% abundant and has a mass of 98.91 atomic mass units. Ruthenium 104 is 2.7% abundant and has a mass of 101.91 atomic mass units. Using this information, calculate the atomic mass or the average atomic mass. So, as a reminder, our goal here is to determine the average mass. And we're going to do that using the sum of the isotope mass multiplied by the fractional abundance for all isotopes. So in this case, there are two, so we'll have two different calculations. So first, we're going to look for ruthenium 99, then ruthenium 104. So there are, for the first one, the isotope mass is 98.91. The fractional abundance is the percent abundance divided by 100. So it can't be the whole abundance, it just needs to be the fractional abundance, which is 0.9730. You're going to add that to 103.91 multiplied by 0.00270. Now we're going to add these. This is the only sig figapalooza we're really going to see this semester. Everything else will be multiplying. What we want to do, because we use calculators, is to just plug all this in. Get an answer, and then say, yeah, our answer should probably only have 3 sig figs. Because that's how many we see here. It turns out that in this case, particularly the way the homework wants you to do it, and me, is that what we'll see is we're going to multiply these together and get 96.24 plus 2.81. And now when we add these together, we will get 99.05 AMU, which is an acceptable answer, even though it has more sig figs than our 2.81 because it was addition. So it's the number of significant figures after the decimal place. So what questions do we have about this calculation? Yeah.
Where are you getting the 98.91 from? I'm sorry. Oh.
It's okay. I was like, so right here, for these, for my graded assessments, everything you need should come out of the problem. I'm not going to ask you. There is a very weird way that I can give you like a data point. You kind of make up the rest of it. In this case, there's another example that is set up the other way. You'll see them. So there's really only 2 ways. It's either that I give you the isotope in abundance for all isotopes, and you basically run this calculation, or I give you the average mass and ask about the other isotope. But I won't be like, this element has 3 isotopes. Here's its mass. Here's information about 1 isotope. Have a good time. That's like a lot. It is mathematically possible to do that. I will not ask you that. I will ask you, like, to do this, or the other example, which we will get to in about 15 minutes. Questions? Yeah.
So we always turn percentages into decimal points.
Yes. So they have to be the fractional abundance. So it is a weighted average. So basically, if you have 10 things in a basket and you want to weigh them, like what is the average mass? If they're all the same, you just divide by the number in there. But if you had tennis balls and bowling balls and, I don't know, shot put, the average weight per round thing would be dependent upon the amount of any one of those in your basket, which is what we're trying to do here. Well enough. Yes, ma'am?
I know in the video for your lecture, we were doing this, and you said not to worry about the amount of sig figs, but you picked the amount of sig figs. So do we still worry about how many sig
if you would like to not have a meltdown with your homework, I would recommend doing it this way. Because Alex does care. I am a little, to be quite honest, I write all my own problems, so I just make it to where when you do all of this, if you do it the normal way, you get the right answer. Because I think this is a little crazy. So it happens more often if any of these are under 10%. If they're over 10%, they all have the same number of sig figs, it doesn't matter. Don't get way deep into them. In the grand scheme of things, they're not all that important. But yeah.
Do we need to know the average mass formula?
You need to know how to do this calculation. Whether you know that formula will not be provided,
Okay.
but you need to know how to calculate it. Yes, ma'am.
Okay, just to clarify, I think you already said this, but when you're multiplying, that's the only time you're doing the sig figs.
So, and when you add them together.
Okay.
So if this had been, I don't know, 5 and 5, and this had like, I'm gonna add some fake numbers, 1 here. When you added these together, you would still get this value because this is not present in that one.
Okay.
I promise this is the hardest sig figs of the whole semester. I'm disappointed it's in the second week though. Any other questions? All right, let's think about something maybe a little bit less mentally taxing. So, who can give me a definition, or who would like to give me a definition, for a molecular formula? Yeah?
Basically like the simplified version of each one, like you would define this, I don't know how to word it well.
It's okay. You are giving me the definition for the empirical formula. So the empirical formula is the formula, the least common denominator version. So what about a molecular formula?
Just basically how many, like exactly how many of each other.
It's exactly who is a part of this. So sometimes you can basically break it down into smaller components. So the molecular formula is everybody who is a part of this. And empirical formula is basically how much of any of these we see. So when we can divide by some value for all of the different elements that are present. The only other formula we have thus far, or at all, is an ionic formula, which is a fancy way of saying a metal and a nonmetal are hanging out together in an ionic compound. So we will see molecules and ionic compounds. If it has a metal, it is an ionic compound, pretty much. So in this case, what is the empirical formula for A? Yes, I can only kind of hear, but I'm not going to make you shout me louder. So I believe that I heard CH2O. So all of those values were divisible by 2. For B, is the empirical formula the same as the molecular formula? Yes. So there is no common denominator. So it is CaBr2. For C, which is benzene, does C6H6 have an empirical formula? Yes, it is CH. What about D? Does it have an empirical formula? Yes. It is KClO3. Any questions about this concept or question? So next, we're going to start to think about protons, neutrons, electrons, and mass numbers. I know it doesn't ask for that in the question, because I forgot about it. But I realized that I almost always ask about mass numbers on graded assessments, and Alex does too. So protons, neutrons, and electrons are basically the things that give elements mass. So I'm going to make a little chart. Protons, neutrons, electrons. Oops. 54. So the 54 is the isotope number. So what is the mass number for manganese 54? Is that the protons? I think you started, that is one of the answers. I'm just. So that is in fact the number of protons, which is the first one. So that's good. You're on the right-ish track. It's okay. So the number of protons in any of these comes off of the periodic table. So if we have our element, we have 25 Mn manganese. And the mass of that is 54.938. So my question is, or a question, for manganese 54, how many electrons, the E? 25. Excellent. So the neutrons is the mass number minus the number of protons. So this 54 right here is your mass number. So how many neutrons are in manganese 54? 29. So when you look at your periodic table, your atomic number, which is basically the whole number in the top of any of these squares, is the number of protons, always, and the number of electrons, provided your element is neutral. So in a second, we have 3 examples of non-neutral things to kind of think about that. Questions? Is anyone percolating on the idea of why is the mass number 54, not 54.9, which we rounded to 55? Is anyone noodling that question around their brain? We got a taker. So, yeah.
I guess because you can't really have 29 of an electron or of a proton. Also, oh wait, I think I remember learning this. It accounts for the electrons since they're smaller than a whole one.
So that's part of it. So this is the average mass. So it accounts for all isotopes. In this case, we're only asking about manganese 54. So you are correct that these are not the same as the whole numbers due to none of them are whole numbers of 1. But it also comes from the fact that you can have manganese 54 and maybe manganese 60, but it looks like you have more of the manganese 54 than of the 60. Because it's that average mass like we did in the problem 2 problems ago. So the mass number does not come from the periodic table. It must come from the isotope information. So if I just gave you like iron, no isotope, you cannot come up with a mass number. Well, I guess no. You couldn't come up with the number of neutrons. So what about iron 57? What is the mass number? 57. How many electrons or protons? What about the number of neutrons? I think you guys said 31. What questions do we have about doing this for a neutral atom? So the next 3 examples are all for ions. When we make an ion, we can do that and make it positive, or we can make it negative, but we can only do that by adding or removing electrons. So your protons never change. You could take that every day this semester and it will be true. So let's look at platinum, 2 plus 195. So what is the mass number for platinum? 195. How many protons are there? 78. How many neutrons? 117. So let's think about the electrons. If it is positive, we have lost 2 electrons, right? So how many electrons are there? Excellent. Let's do the negative ion. So 75, arsenite 3 minus. So from here, in this case, we know that the mass number is 75. The protons are 33. The neutrons are 42. So how many electrons are there? 36. Correct. Questions, thoughts, I won't say comments, but any questions about these type of, not really a calculation, but these type of questions? This is a prime example of somewhere where like you don't need to show work. There really isn't any work to be shown. You might have like some scratch calculations, but you don't need to write like protons plus neutrons equals mass number. It works. We are going to come back to this question. So the next topic is, so in the videos we've started to think about how you can merge these two things. We have anions and cations, and so now we want to start to make compounds. So moving forward, starting next week, we're going to start to call them by their names. But the first step of that is to be able to say things like, what chemical formula would you expect? So on mini exam 1, if I gave you a table like this and asked what is the chemical formula of this, you should be able to do that. So it would look like this, where any polyatomics would come with the charge. Does that help? And if it is a transition metal, the ones where they could be multiple states, I will indicate which state it is by adding the Roman numerals like it will be in the name. So if you've watched the videos, it talks about how you name them with Roman numerals. So the Roman numerals in this table tell us that means that is vanadium 3+. We can move forward with that. So I'm not going to ask you to generate the names or the formulas from the names, just to generate the formulas from the either neutral or polyatomic ions. Does that make sense? About what is going to be expected next week? Excellent. Also, on really large font, you can see the negative ions really clearly. When I print these on the exams, if you're starting to ask yourself, is that a -2 or just like you dropped your pen on the page, feel free to ask. I'm happy to answer that question. So for calcium and bromine, what is the charge on calcium? 2+. What about bromine? So how many bromines do you need in order to create a neutral ion? 2. So your chemical formula would be CaBr2. What questions do we have about this type of question thus far? Yeah.
Is the charge just the column number? Is it CA?
So yeah, so in the periodic table, in the videos, it talks about how we have the transition metals, which can adopt multiple states, but by and large, as we go across, it's +1, +2. Yeah. No, it's okay. So you could, on your periodic table that you're not going to carry around with you all the time, label across the top, which is what I would do, what the charge states are for any of those. For the transition metals, it's not, you will have to use context clues. Now, not in a way of like reading context clues, like in those old days, but it would either be that I would give you the 3 that tells you it's a +3, or you could, once we have the formula, be able to go backwards to the other direction. We're going to get to that in a second. So next we have copper 1, which is a copper plus, and oxygen. So what is the chemical formula for copper 1 oxide? I'm hearing some CU's and some O. Do either of these have a subscript? Is this what we mean? Yes. So in this case, because copper only has a +1, the oxygen has a 2-, so we need 2 coppers for every 1 oxygen. Questions? What about Kn? So potassium is a +1, nitrogen is a -3, so it's K3N. So the next one is vanadium 3. So that means it's a V3+. And the sulfate ion, which is SO4 2-. So for mini exam 2, if the word said vanadium 3 sulfate, you'll need to be able to back generate that. In this case, I'll give you all that. So in this case, what is the chemical formula for vanadium 3 sulfate? Vanadium 2, SO4, 3. So a moments ago, I talked about how you could back calculate. So in the future, if I gave you this chemical formula and you were like, what is the oxidation state of vanadium? The way you would get to that information is you could figure out the charge on, you would know the charge on the sulfate ion, which is a -2, times 3, which would be -6, divided by 2 would give you a +3. That will be how you will get through the naming process, if that makes sense. Questions about vanadium V2SO4? 3. Yeah.
I'm just a little confused with like balancing the like electrons, like the +3, like the -2. Like, do they just kind of like give to each other to like balance?
So the goal is that you want it to be neutral. So the question is, not really, but kind of how did we get to this? So if we know that vanadium has a 3+, and this has a 2-, we need them to be neutral. And the way we can get to that is by figuring out how many vanadiums and how many sulfates we have to have. Up until this point, you could basically just add some more of the other one. In this case, we have to balance this. So you can use it looks like the do-si-do, but I'm from Texas, and so I think about things in terms of square dances. So basically, this charge and this charge switch on the partners. So you get a 2 and a 3 here, because it will basically give you a whole number. More than likely, that's about, I don't know that they get a lot more complicated than that. It's really just a cation and an anion. The biggest thing to note is that you cannot redistribute these over that. I will post the key for how to do this problem in the question because it's 5:45 and I didn't realize. If you have questions, feel free to pop on down. Otherwise, I will see you on Wednesday.